Hi everyone, welcome to this video on C7 organic chemistry. So we're going to be focusing on hydrocarbons, alkanes, alkenes and also fractional distillation today. So let's start with what a hydrocarbon actually is. So all hydrocarbons are compounds that contain only hydrogen and carbon. So there's nothing else in there but hydrogen and carbon. So there's two types of hydrocarbons that you need to know about. The first one is alkanes and the second is alkenes. Okay, so the main differences then, let's talk through them. So alkanes have only carbon to carbon single bonds. Okay, and that line in the middle there that I've just drawn represents a bond. It's how those carbons are attached together. Alkenes, on the other hand, have a carbon to carbon double bond present. Okay, alkanes, there's a few that you need to know and you need to be able to draw them as well, so we'll talk through that in a moment. But alkanes are known as saturated compounds, and what that means is that they just have single bonds, that's all. They're just known as saturated compounds. And let's just draw a line there. And alkenes are known as unsaturated compounds, and they're unsaturated because they have that double bond. Okay, so let's show you how to draw them. So I'll just put alkanes on this side and I'll put alkenes here. So in order to draw them, you need to know how many carbons are present. The starting word, meth, tells you there is one carbon present. Eth means there's two carbons present. Prop means 3 carbons present. Bute means 4 carbons present. And pent means 5 carbons present, and hex means there's 6 carbons present. Now, if I'm talking about an alkane with 1 carbon, the ending would be ANE. However, if I'm talking about an alkene, let's say an alkene with 2 carbons, then the ending would be ethene. So it's either ane or ene, depending on whether it's an alkene or an alkane. So the starting part of the word basically tells you how many carbons there are. So if I want to draw, let's say I want to draw propene. So propene, it's an alkene, which means it's got a carbon to carbon double bond. So prop means 3 carbons. So you draw in your 3 carbons like this. However, because it's an alkene, it means there's a double bond. So you draw 1 double bond somewhere in the chain. It can be there or it could be there, it doesn't really matter, but make sure there's only 1 carbon to carbon double bond out the whole chain. So don't start drawing double bonds between all the carbons, that would be wrong. There's only 1 carbon to carbon double bond through the whole chain. Okay, now we need to know how to draw in our hydrogens, because remember, alkanes and alkenes are hydrocarbons. Each carbon can only have 4 bonds around it, no more and no less. So let's start with this carbon, it's got 1. We draw in 2, 3, 4. These are our hydrogens. Let's look at this carbon, it's got 1, 2, 3, so it only needs 1 more attached to hydrogen. This one has 1, 2, 3, 4. Let's attach the hydrogens like that. So that is propene. This is the displayed formula, and displayed means showing all the bonds for propene. But let's draw propane just so you can see the difference between them. So propane on this side has 3 carbons but no double bond because it's an alkane. So let's start here again. So 1 bond, 2, 3, 4, this carbon, 1, 2, 3, 4, and this carbon, 1, 2, 3, 4. So you can see that alkanes have more hydrogens than alkenes. There's actually a formula that you need to know, and it's called a general formula for alkanes and alkenes. So for alkanes, the general formula is CnH2n plus 2. It's just a bit of maths where n could be any number. So let's say n is 50. And the question might say, what's the formula for the alkane with 50 carbons? You would use this formula to work it out. So C50, H, so H is 2n. So 2n is 2 times 50, which is 100, plus 2. So your total formula is C50, H, 102. It just saves you drawing out the whole thing. You know, you can't draw 50 carbons with all the hydrogens around them and count them. It would take too long. So this is just sort of a cheat way of working out how many carbons there are and how many hydrogens there are for alkanes. So the general formula for alkenes, is CnH2n. So again, let's say n is 100. So it'd be C100, H, 2n means 2 times n, 2 times 100 is 200. So the answer is C100, H200. Okay, so that's your alkanes and alkenes. We just need to know about the properties and how, sorry, my pens are running out. The properties of hydrocarbon chains. So it's to do with size. So the length of the carbon chain basically changes the properties of the hydrocarbon. So the shorter chains, so we're talking about the chains with maybe 2, 3, 4 carbons in it, are more runny, so they're sort of more liquidy. They are less viscous, and all that means is less gloopy, so less gloopy, so you know that makes sense. They're more runny and less gloopy. They're more flammable, so they easily ignite, and they have lower boiling points. And the reason for this is because if it's a shorter chain, let's say it's just ethane, for example, you don't need as much energy to break down ethane, to break down these bonds, as you would for something with 50 carbons, for example. You know, so you don't need as much heat energy in order to break down the chain, so they have lower boiling points. Okay, so that's all we really need to know about hydrocarbons. Just one other thing I'll quickly go over with you is complete combustion, because sometimes this involves hydrocarbons. So complete combustion is when there is plenty of oxygen present. So the general sort of equation for this is hydrocarbon plus oxygen, plenty of oxygen, goes to carbon dioxide and water. So it's quite similar to just reacting carbon and oxygen. So you might have seen this complete combustion reaction, but you only make carbon dioxide when there's only carbon present. But because we've got hydrocarbon present, you make water as well, because hydrogen, that wouldn't just disappear, it has to react with something in order to make a product. So water is made if you're doing complete combustion of a hydrocarbon, as opposed to just making carbon dioxide when you're reacting carbon. Right, so fractional distillation. So fractional distillation is a separation technique. So a separation technique for mixtures. So remember, mixtures are not chemically bonded together and can be separated, and fractional distillation is one way we can separate out crude oil. Now crude oil is made up of so a mix of hydrocarbons, lots of hydrocarbons, okay? Hydrocarbons such as petrol, diesel, jet fuel, things like that, which we need to separate, because when you go and fill up your car at the petrol station, you can't fill it up with a mix of petrol and diesel. It's either petrol that you fill it up with or diesel, so we have to get them separated from this crude oil. So how we do that, and I'm going to draw excuse me, I'm going to draw the fractionating column for you, label it and talk you through it. So it's just this tall column like this, and this is called a fractionating column. Okay, so at the bottom of the column you get your liquid crude oil pumped in. Okay, liquid crude oil is pumped in at the bottom of the fractionating column. At the bottom it is extremely hot, and as you go up the column it gets cooler. Okay, so there is a temperature gradient in the column, hottest at the bottom and coolest at the top. So the liquid crude oil is pumped in, and because it's so hot at the bottom of the column, the crude oil vaporizes, which means it turns into a gas. So that liquid crude oil turns into a gas, it vaporizes. Gases are less dense, so they rise. So the crude oil mixture, which is now a gas, begins to rise. So let's say one thing in our crude oil mixture is diesel. Now, let's say at this temperature here, I'm just going to make up some numbers. At 600 degrees, my my diesel has hit its boiling point. So diesel condenses at this temperature. Condenses means turns into a liquid. So it turns into a liquid and is collected as a fraction. So it's collected separately in liquid form as a fraction. And a fraction just means sort of like a section. And in here would be my diesel. The rest of the crude oil mixture continues to rise until, let's say, I've hit something else's boiling point, like petrol. And I'm going to say petrol, again making up numbers here, has a boiling point of 300 degrees. So petrol condenses at its boiling point and is collected separately as a fraction. So collected as a petrol fraction. And this just continues to happen all the way through the column, so that you separate out all the different hydrocarbons that are in that mix of crude oil. So it's really important in an exam question that you mention things like the temperature gradient, it's really hot at the bottom and cooler at the top, that you mention the liquid crude oil is pumped in and it vaporizes. All these different words, all these key words will get you the mark. Talk about the fractions being collected separately, and that's why it's called a fractionating column. That's why it's called fractional distillation, because we end up with different fractions from the mixture of crude oil.